Welcome to Spring LIB.
The problem is the blood vascular system consists of blood vessels that convey blood from the heart to the organs and back to the heart. This system should work so as to minimize the energy expended by the heart in pumping the blood. In particular, this energy is reduced when the resistance of the blood is lowered. One of Postle's laws gives the resistance R of the blood as R is equal to C times L over R to the power of 4, while L is the length of the blood vessel, R is the radius, and C is the positive constant determined by the viscosity of the blood. Now let's look at the figure. The figure shows a main blood vessel with radius R1 branching at an angle theta into a smaller vessel with radius R2. The problem part A use Postle's law to show that the total resistance of the blood along the path ABC is R is equal to C times A minus B cotangent theta over R1 to the power of 4 plus B times C cosecant theta over R2 to the power of 4. For part A, the Postle's law is R is equal to C times L over R to the power of 4. So now let's look at this graph. We can see AB is equal to A minus B times cotangent theta. So we have AB is equal to A minus B times cotangent theta, and BC is equal to B times cosecant theta. Then we use the Postle's law. We have R is equal to C times A minus B cotangent theta over R1 to the power of 4 plus B times cosecant theta over R2 to the power of 4. Part B, prove that this resistance is minimized when cosine theta is equal to R2 to the power of 4 over R1 to the power of 4. So we take derivative, dr d theta. This is equal to B C times B over R1 to the power of 4 times cosecant theta square minus B over R2 to the power of 4 cosecant theta times cotangent theta. So this is equal to C times B cosecant theta square over R1 to the power of 4 times 1 minus R1 to the power of 4 over R2 to the power of 4 cotangent theta over cosecant theta. But here, cotangent theta over cosecant theta is equal to cosine theta. If we let dr d theta is equal to 0, we have cosine theta is equal to r1 to the r2 to the power of 4 over r1 to the power of 4. So when theta is greater than cosine inverse r2 to the power of 4 over r1 to the power of 4, we have dr d theta is greater than 0. And when theta is smaller than this number, then dr d theta is smaller than 0. Then we have when theta is equal to 1 arc cosine r2 to the power of 4 over r1 to the power of 4, or cosine theta is equal to this number, r has the minimum value. Part C. Find the optimal branching angle when the radius of the smaller blood vessel is 2/3 the radius of the larger vessel. So we have r2 over r1 is equal to 2/3. So cosine theta is equal to 2/3 to the power of 4. So theta is about 79 degrees.